Welcome to aminacademy.com. In physics, let us discuss about viscosity, surface tension, and capillary rise. First, we will discuss about viscosity. Most of the fluids are not ideal ones and offer some resistance to motion. This resistance to fluid motion is like an internal friction analogous to friction when a solid moves on a surface. It is called viscosity. This force exists when there is relative motion between layers of the liquid. Suppose we consider a fluid like oil enclosed between two glass plates, so it offers viscous force. Viscosity is the resistance of a fluid, liquid or gas to change its shape or movement of neighboring positions relative to one another. Viscosity denotes opposition to flow. Now, for any layer of liquid, its upper layer pulls it forward while lower layer pulls it backward. This results in force between the layers. This type of flow is known as laminar flow. The layers of liquid slide over one another as the pages of the book do when it is placed flat on a table in a horizontal force is applied to the top cover. When a fluid is flowing in a pipe or a tube, then velocity of the liquid layer along the axis of the tube is maximum and decrease gradually as we move towards the walls where it becomes zero. Now, surface here we will do the viscous force further detail. The ratio of the shearing stress to the shearing rate, that is eta equal F by A over V by L, that is equal to FL by UVA. In SI units, viscosity is Poisson. Its other units are Newton second per meter square or Pascal second. Now, units of viscosity. Units is first units of viscosity, before that eta equal stress by strain is V by L, therefore which is equal FL by VA. The unit equal Poisson. Poisson, then which is Newton second per meter square or Pascal second. Different liquids have different viscosity. Now, next, Stokes law. When a body falls through a fluid, it drags the layer of the fluid in contact with it. A relative motion between the different layers of the fluid is set, and a result, the body experiences a retarding force. Falling of a raindrop and swinging of a pendulum, bob are some common examples of such motion. It is seen that the viscous force is proportional to the velocity of the object and is opposite to the direction of the motion. The other quantities on which the force F depends are viscosity eta of the fluid and radius of a sphere. Stokes' law is an empirical law for the frictional force, also called drag force, exerted on a spherical objects with very small Reynolds numbers in a viscous fluid. It was derived by George Gabriel Stokes in 1851 by solving the Stokes flow limit for small Reynolds number of the Navier-Stokes equations. Here, the force from Stokes' law, we can get the force is equal to 6 pi r eta v, where F is a drag force, pi r is a square radius in meter, eta equal to fluid viscosity, v equal to velocity of the sphere. Next, surface tension. You must have noticed that oil and water do not mix. Water wets you and not the water normally wets us, but not ducks. Mercury does not wet glass, but water sticks to it. Oil rises up a cotton wick in spite of gravity. Sap and water rise up the top of the levers of the tree. Hair of a paintbrush do not cling together when dry and even when dipped in water, but form a fine tip when takes out of it. All this and many more such experiences are related with the free surface of liquids. As liquids have no definite shape but have a definite volume, they occur a free surface when poured in a container. This surface possesses some additional energy. This phenomenon is known as surface tension and it is concerned with only liquid as gas do not have free surfaces. Surface tension is the tendency of a liquid surface at rest to shrink into the minimum surface area possible. Surface tension is what allows objects with a higher density than water such as razor blades and insects, that is water striders, to float on a water surface without becoming even partly submerged. Look at this here fly is simply sitting on a surface of the water because of the water surface tension forces push the leg upward, so it can easily float. Look at here that even the pin is float, looks like a float on a surface of the water. It's not a float. It's due to the surface tension of the water. There's the force push upward, that is upward the pin. So due to the surface tension of the water, it can float. Any raindrop mostly it's a spherical shape because of the surface tension force of the water. Surface tension is defined as a force per unit length acting perpendicular to the tangential line on the surface. It is due to imbalanced attractive forces acting downward and tends to reduce the surface area of a liquid to minimum. Next, we will talk about surface energy. A liquid stays together because of attraction between molecules. Consider a molecular well inside a liquid. The intermolecular distances are such that it is attracted to all the surrounding molecules. This attraction results in negative potential energy for the molecule, which depends on the number of distribution of the molecules around the chosen one. But the average potential energy of all the molecules is the same. This is supported by the fact that to take a collection of such molecules like liquid and to disperse them far away from each other in order to evaporate or vaporize. The heat of evaporation required is quite large. For water, it is order of 40 kg per mole. Now, the surface energy. Surface energy quantifies the disruption of intermolecular bonds that occurs when a surface is created. It is also called surface free energy or interfacial free energy. In simple language, surface energy can be defined as the work per unit area done by the force that creates the new surface. Here, this high surface energy is like and low surface energy is like. Here, the dome is higher. Now, let us discuss further about surface energy and surface tension. The attractive force of the molecules present at the surface of a liquid towards each other is called the surface tension of that liquid. But surface energy is the equivalent attractive force present between the molecules at the surface of the solid substances. Here, higher surface energy and high, if you go up, it is a higher surface tension non-wetting conditions. These are low surface energy non-wetting but high surface tension, like it's varying. Next, angle of contact. So, the angle subtended between the tangents drawn at liquid surface and at the solid surface inside the liquid at the point of contact is called a angle of contact. Here, look at this, low contact angle, high surface energy, having low contact angle. High contact angle have low surface energy. Drops and bubbles. Because of the surface tension, as the wall tension required for the formation of drops or bubbles is provided. The tendency to minimize the surface area causes the wall tension to be pulled inwards, directed at all sides, thereby leading to a spherical shape. Any water drops from the raindrop or some from falling object, that what becomes mostly it is a spherical shape because it have the surface tension is tendency to reduce the total surface area of the formation of the bubbles. So it always mostly it looks like a spherical shape. Next, capillary rise. One consequence of the pressure difference across a curved liquid air interface is the well-known effect that water rises up in a narrow tube in spite of a gravity. The word capilla means hair in Latin. If the tube were hair thin, the rise would be very large. That means diameter of the tube inside a hole is very less, then rise will be more. To see this, consider a vertical capillary tube of particular cross section, that is a radius, inserted in an open vessel of a water. So the water rises up inside the tube. The contact angle between water and the glass is acute, thus the surface of a water in the capillary is concave. This means that there is a pressure difference between the two sides of the top surface. This is given by P1 minus P0 equal to 2S by R. That means, therefore, pressure difference is we can write is 2S by 2S A into cos theta. This is a capillary rise. Now, capillary rise or capillarity is a phenomenon in which liquid spontaneously rises or falls in a narrow space such as a thin tube or the voids of a porous material. Look at here, this very thin tube, due to surface tension, the water rises up inside the tube. It's called a capillary rise. Capillarity rise is due to the tendency of liquids to rise in tubes of small diameter in opposition to the gravity. This is a force opposite to gravity, it raises up. Capillarity fall is due to the depression of a liquid in tubes of small diameter in opposition to gravity. The capillary action rises due to the adhesive and cohesive forces, because this is the tendency to capillary rise is due to adhesive and cohesive forces. Now capillary rise formula H equal 2t cos theta by PGR, where H equal to elevation of the liquid in meter, T equal to surface tension in Newton per meter, theta is angle of contact, P equal to density, rho equal to density of the liquid in kg per meter cube, and G is standard acceleration due to gravity in meter per second square, R equal to radius of the capillary tube in meter. This is the formula for capillary rise. So far we have done is first viscosity, Stokes law, and surface tension, surface energy and surface tension, angle of contact, drops and bubbles, and capillary rays. We have done. Please subscribe our YouTube channel.